Before Albert Einstein revolutionized our understanding of the cosmos, humanity viewed space and time as rigid stages. These were unchanging platforms upon which the grand events of the entire universe played out daily. Einstein shattered this perception by introducing his special theory of relativity to a skeptical scientific world. This revolutionary theory is built upon two radical postulates that fundamentally altered our view of reality. First, the laws of physics remain identical for any observer moving at a constant, steady speed. This implies there is no absolute state of rest anywhere within the vast, expanding cosmic void. Imagine sitting in a windowless airplane cabin, pouring a glass of water with perfect, calm ease. The physics of that water pouring remains identical to the physics experienced in your kitchen home. There is no experiment you can perform to determine your absolute speed through the silent void. Second, the speed of light is a universal constant that never changes for any moving observer. Regardless of the observer's motion, light maintains its velocity, acting as the ultimate cosmic speed limit. This second rule forces reality to bend in unexpected ways to preserve this strict cosmic limit. When we attempt to reconcile these two postulates, we discover a startling truth about our universe. Space and time are not fixed backgrounds, but are instead fluid dimensions that constantly shift around. They warp, stretch, and contract depending on how fast an object travels through the dark vacuum. This discovery fundamentally alters our perception of reality and challenges the foundations of classical Newtonian physics. Newton believed in an absolute clock, but Einstein proved that time itself is a flexible, subjective. The rigid stage of the universe begins to ripple like water under the influence of motion. Observers moving at different speeds experience the passage of time in vastly different, unique, personal ways. Distances shrink and expand, defying the intuitive logic that governed human thought for many long centuries. The very fabric of existence becomes an elastic medium, responsive to the velocity of every traveler. We are no longer static spectators watching events unfold on a stationary, predictable, and solid stage. Instead, we are participants in a dynamic, fluid dance where every movement changes the cosmic geometry. Einstein's insights dismantled the clockwork universe, replacing it with a vibrant, interconnected, and shifting relativistic tapestry. This shift in perspective opened the door to understanding gravity, black holes, and the expanding universe. By accepting these postulates, we acknowledge that our senses often deceive us regarding the true nature. The universe is far more complex and interconnected than our simple daily experiences would ever suggest. Time and space are woven together into a singular, malleable fabric that defines our physical existence. Every object and every ray of light tells a story of motion, relativity, and hidden connections. Einstein invited us to look beyond the surface of things and into the deep, underlying structure. His work remains the cornerstone of modern physics, guiding our exploration of the stars and beyond. The rigid, unchanging stage of the past has vanished, replaced by a fluid, living, breathing cosmos. We continue to unravel the mysteries of this relativistic world, one experiment and one equation today. Consider the implications of a light beam traveling alongside a car moving at high speeds. You might expect the light to appear slower, but nature strictly forbids such a simple addition. The light maintains its constant, blistering pace, regardless of the car's velocity or your own motion. To keep this speed constant, the universe must sacrifice the stability of time and physical distance. This is the core of the mystery that Einstein unraveled with his elegant, groundbreaking mathematical equations. The constancy of light is the anchor that forces the rest of reality to become relative. Without this anchor, the laws of physics would crumble under the weight of conflicting, impossible observations. We live in a universe where the speed of light dictates the rules of the game. It is a cosmic referee that ensures every observer, regardless of their speed, sees the same. This creates a beautiful, complex symmetry that governs the behavior of everything from atoms to galaxies. As we delve deeper, we see that motion is not just a change in position here. Motion is a transformation of the very space and time that we inhabit every single day. The faster you move, the more the universe adjusts to maintain its internal, logical, physical consistency. It is a dance of proportions where time slows down to accommodate the speed of light. Simultaneously, space contracts to ensure that no object ever exceeds that ultimate universal speed limit. This is not just theory. It is the fundamental reality of our vast, expanding, relativistic universe. We are learning to see the world through the lens of Einstein's profound and beautiful vision. Every measurement we make is tied to our own state of motion within this cosmic web. There is no privileged viewpoint, only the relative experiences of observers moving through the great expanse. This realization changes how we define distance, duration, and the very nature of our physical reality. We are travelers on a journey through a universe that is far more flexible than imagined. The two postulates provide the map for navigating this strange, new, and deeply interconnected physical landscape. As we accelerate, we peel back the layers of illusion to reveal the underlying, elegant truth. The universe is a masterpiece of relativity, waiting for us to understand its hidden, complex rules. With every step, we gain a clearer picture of the forces that shape our cosmic home. Einstein's legacy is a testament to the power of human curiosity and the beauty of physics. Let us continue our exploration into the heart of this fluid, bending, and truly magnificent universe. As an object accelerates toward the speed of light, the universe undergoes a series of transformations. These mind-bending changes occur specifically to maintain the absolute consistency of light speed for every observer. Time dilation causes clocks to tick significantly slower for those in high-speed motion through the cosmos. This phenomenon effectively allows travelers to journey into the distant future, relative to those left behind. Simultaneously, length contraction causes objects to physically shrink along their specific direction of travel through space. The famous equation E equals mc squared dictates that as energy is added to increase an object's speed, the object gains mass, eventually requiring near infinite energy to reach the speed of light itself. These phenomena demonstrate that space, time, and mass are inextricably linked in a complex, elastic dance. Ultimately, special relativity reveals that our universe is not a static environment or a rigid stage. Instead, it is a dynamic, relative experience where the passage of time is never truly absolute. The dimensions of space are entirely dependent on the observer's unique journey through the vast cosmos. Einstein proved that reality is fluid, shifting constantly based on our velocity through the cosmic fabric. We no longer inhabit a fixed clockwork universe, but a flexible, interconnected web of relative motion. Every movement we make ripples through the dimensions, altering the fundamental geometry of our shared reality. This realization fundamentally changed how we perceive the stars, the planets, and our own existence. By linking energy and matter, Einstein unlocked the secret language of the stars and deep space. The cosmic speed limit acts as a gatekeeper, ensuring that causality remains intact across the universe. As we push faster, the fabric of space-time reacts, bending to accommodate our relentless forward momentum. Clocks that once ticked in unison now drift apart, separated by the invisible currents of velocity. Distance itself becomes a subjective measurement, changing shape as we traverse the dark, silent void. Mass grows heavy with the burden of kinetic energy, resisting further acceleration toward the light's limit. It is a beautiful, mathematical choreography that governs the behavior of everything from atoms to galaxies. We are merely travelers navigating a sea of relativity where every path creates a unique perspective. Einstein's legacy is the understanding that our perception is limited by our own motion through space. The universe remains a mystery, yet we now hold the keys to deciphering its complex mechanics. Every observation is a dialogue between the observer and the fundamental laws of the physical world. We see the universe not as it is, but as it appears from our specific vantage. This shift in perspective opened the door to modern astrophysics and our exploration of deep space. The elastic nature of time and space continues to challenge our intuition about the natural world. Yet, the math remains consistent, providing a reliable map for our journey through the infinite expanse.